Tonight, if you stand in an open field far from city lights and look up, you will see something ancient, a faint smudge, barely there, dissolved into the darkness like a ghost that was not quite sure it wanted to be seen. That is the Andromeda Galaxy, 2.5 million light years away. So far that if light itself started the journey right now, it would arrive 2.5 million years from now, long after every human being alive today is gone, long after our species may have changed into something unrecognizable. But here's the thing that matters more than its distance. It is coming toward us, directly toward us. The Andromeda Galaxy, that faint smudge you can barely see on a clear, dark night, is moving toward our Milky Way at 110 kilometers per second. In the time it takes you to finish reading this sentence, Andromeda has moved another 550 kilometers closer to us, and 4 billion years from now, these two galaxies will collide. Or rather, they will merge. They will pass through each other, be pulled back by gravity, pass through again, and over billions of years slowly become something new. Something that is neither Milky Way nor Andromeda. Something that has never existed before. This is the story of that collision. What will happen, what it will look like, what it will destroy, what it will create, and why, of all the things happening in the universe right now, this might be the one most worth thinking about. Before we go forward, we need to understand what we are actually dealing with. We live inside the Milky Way, a spiral galaxy roughly 100,000 light years across, containing somewhere around 200 billion stars. Our sun is one of those 200 billion, not especially bright, not especially dim. An average star in an average location, sitting about 2/3 of the way out from the galactic center. Andromeda is bigger. Andromeda contains roughly 1 trillion stars, 5 times more than the Milky Way. It is also a spiral, and when you look at it through a telescope, you can see its arms, its disk, its shape. It looks almost like a mirror of our own galaxy, placed across the void. But Andromeda is more than a collection of stars. It is a time machine. When you look at that faint smudge in the night sky, the light entering your eye left Andromeda 2.5 million years ago. It has been traveling ever since, crossing empty space, threading through star fields. And tonight it ended its journey in your eye. 2.5 million years ago, when that light began its journey, the first humans who shaped stone tools were just walking the earth. Our ancestors. The beginning of something that would eventually become us. That light has been traveling since before our kind could think. To look at Andromeda is to look 2.5 million years into the past. And in that same sky, right now, Andromeda is drifting closer, slowly, invisibly, but with absolute certainty. How do we know any of this? That is the question worth asking, because the Andromeda collision is not a guess. It is not a rumor from astronomers. It is a prediction built from real measurements, confirmed multiple times, checked against the laws of physics. The key came in 2012 from the Hubble Space Telescope. Over the course of years, Hubble tracked individual stars inside Andromeda, not just their brightness, their actual positions over time, watching where they moved. When astronomers compiled those measurements, one thing became impossible to ignore. Andromeda was not drifting sideways. It was not passing by. It was coming straight at us. For a long time, scientists had held out hope that maybe Andromeda would be a near miss, a glancing blow, that the two galaxies would pass close but not fully collide. Hubble's precise measurements ended that hope. This is a direct, head-on merger. And Andromeda does not come alone. It has a companion. The Triangulum Galaxy, also called M33, a smaller spiral that orbits Andromeda the way a moon orbits a planet. Triangulum is also being pulled into this encounter. 3 galaxies, 1 slow catastrophe, 4 billion years from now. To understand exactly how the merger will unfold, NASA scientists ran what are essentially the most complicated simulations of gravity ever attempted for this scenario. They modeled billions of particles, each one representing a star or a cluster of stars, and let the laws of physics play out forward in time. They ran these simulations again and again, varying the starting conditions, looking for what was consistent across all possible outcomes. What emerged was clear and consistent enough to say with confidence: 4 billion years from now, the Milky Way and Andromeda will merge into a single galaxy. Now comes the part where most people's instincts lead them in completely the wrong direction. When you hear the words galaxy collision, the mind wants to picture an explosion. Stars crashing into each other like cars on a highway. Destruction on an unimaginable scale. That is not what happens. The most mind-bending thing about galaxies is just how empty they are. Here is a way to feel it. The Milky Way is 100,000 light years across. But if you replaced our sun with a soccer ball and placed it in the middle of a field, the nearest other star, Proxima Centauri, would be roughly 4,300 kilometers away, approximately the distance from London to New York. Sitting in an empty field between them would be nothing. No other stars, just void. Galaxies are not crowds. They are vast dark oceans with a few lonely lights floating impossibly far apart. When two galaxies merge, the stars almost never directly collide. The probability of any two stars hitting each other during the entire Milky Way Andromeda merger is so astronomically small that astronomers consider it essentially zero. Our sun will almost certainly never get within a light year of any star from Andromeda. What happens instead is gravity. As the galaxies approach, their gravitational fields begin pulling on each other from across the void. Stars are dragged out of orbits they have held for billions of years. The great spiral arms, structures that took billions of years to form, begin to warp and stretch and pull apart. Tidal forces throw long streams of stars out into space like water flung from a spinning wheel. The merger happens in stages. First, the two galaxies will pass through each other, interpenetrating like two ghosts walking through the same wall. Then gravity will pull them back together. A second pass. A third. Each time more mixing, more disruption, more stars thrown into completely new trajectories. This whole process, from first contact to final merger, will take roughly 2 billion years. And what forms at the end already has a name that astronomers have given it: Milkomeda. The merged galaxy will not be a spiral. The great pinwheel of the Milky Way, the sweeping arms of Andromeda, both will be gone. What remains will be an elliptical galaxy. A large, smooth, roughly oval structure with no dramatic arms, no spinning disk. Just a sphere of stars, drawn from both galaxies, orbiting a shared center. Quieter, older looking, but containing within it every star that existed in either galaxy. So what happens to us specifically? What happens to our sun, our Earth, our small corner of all of this? The answer is complicated, and it depends on which simulation you look at. In most outcomes, our sun survives. Since stars almost never directly collide, the sun will be gravitationally disturbed, pulled into a new orbit, sent on a different path through the merged galaxy. But it will almost certainly not be destroyed by the collision itself. In some simulations, our sun ends up near the center of the merged galaxy, much closer to the dense core than it is today. In others, it gets flung far out to the edges, into the quiet outskirts of Milkomeda. In one scenario out of 12 that NASA modeled, our sun ends up transferred entirely to what was originally the Andromeda side of things, technically making our solar system an Andromeda star by the end. But here is the thing that puts all of this into perspective. The Andromeda collision is not what will end life on Earth. Our own sun will do that first, and much sooner. In roughly 1 billion years, the sun will brighten enough that Earth's surface temperatures will begin to climb past the point where liquid water can exist. The oceans will evaporate. The atmosphere will change. Complex life, as we know it, will become impossible. In about 5 billion years, the sun will exhaust its core hydrogen and swell into a red giant, expanding to potentially swallow Earth entirely. The sun's transformation begins in 1 billion years. The Andromeda collision is 4 billion years away. This means that by the time Andromeda arrives, whatever the universe has where Earth used to be will be something we cannot imagine from here. If anything is here at all, it will not be us. It will be something that came after everything we know, something born in a future so distant that our entire recorded history would be invisible against it, too small to measure. But let us imagine something is here. Let us imagine that 4 billion years from now, some form of awareness exists somewhere and looks up at the sky. What do they see? Tonight, Andromeda is a faint oval smudge on the darkest nights. You have to know where to look, and even then, it is easy to mistake for a wisp of cloud. The light is there, but barely. 1 billion years from now, that will have changed completely. Andromeda will have grown visibly larger in the sky. As it draws closer, its angular size expands. It will be unmistakable. A glowing structure spanning a significant portion of the night sky, visible even in moderate light. 3 billion years from now, just before first contact, Andromeda will be enormous. A vast, luminous spiral filling the sky from horizon to horizon, brighter than anything except the sun and moon. You would not need to know where to look. You could not miss it. And then the collision begins. and the sky becomes something no human eye has ever seen, and no human mind has fully imagined. Stars from both galaxies are flung into new positions. The clean shapes of the two spirals dissolve into sweeping arcs and streams of light crossing the sky in every direction. Gas clouds are compressed by the collision, triggering enormous bursts of new star formation. Regions of sky that were dark suddenly light up with nurseries of new suns being born. Astronomers have a name for this: a starburst. When galaxies merge, they do not just rearrange existing stars, they create new ones. The violence of the collision becomes the engine of creation. Millions of new suns, born in the turbulence, each one a possible center for new worlds. The night sky during the collision would look nothing like the sky we know. No clean constellations, no familiar shapes, just an overwhelming blaze of structure and light in every direction, the entire history of two galaxies being rewritten across the dark. We cannot look into the future, but we can look across the present. The universe is old enough and large enough that somewhere out there, other galaxies are already going through what our Milky Way and Andromeda will go through. We can find them, study them, watch the same process unfold in real time, billions of light years away. The Andromeda Galaxies, two spirals actively merging right now. Their long tidal tails stretch across space, pulled out by mutual gravity. Their centers are slowly spiraling toward each other. Gas clouds in the overlap region are exploding with new star formation. They are not dying, they are building something. The Mice Galaxies, another merging pair, named for the long tail of stars that gravity has ripped from each one, trailing behind them as they move. Stephan's Quintet, a compact group of galaxies interacting gravitationally, tugging on each other, exchanging stars, slowly changing each other's shapes. There are hundreds of examples. Galaxies at every stage of merger, spread across the visible universe, each one a data point. Scientists look at these real collisions, build models that match what is observed, and then apply those same models to our own pair. We know what is coming for the Milky Way because we can already see the same thing happening to other galaxies. The prediction is not extrapolation from theory alone. It is pattern recognition across the observable universe. Dozens of real galaxies, all telling the same story. Before we go further, let us make the numbers real. 4 billion years. Written out, 4 billion. The Earth itself is 4.5 billion years old, so the time remaining until the collision is roughly equal to the entire age of our planet. Modern humans have existed for about 300,000 years. 4 billion years is more than 13,000 times that span. If the entire history of our species were compressed into a single day, the Andromeda collision would not happen until 35 years from now. In the scale of what will merge, the Milky Way holds roughly 200 billion stars. Andromeda holds roughly 1 trillion. The merged galaxy will contain approximately 1.2 trillion stars, 1.2 trillion suns, each one a potential center for a solar system. Each solar system, a potential home for something. All of them rearranging themselves over 2 billion years into a new configuration, governed by nothing but gravity and time. This is not a local event. It is not something happening in one corner of space. It is one of the largest gravitational events our region of the universe will experience across billions of years in either direction. And we are inside one of the two galaxies involved. We are already part of it. We just have a long time to wait. There is one more piece of this story that most people do not know, and it is the strangest part. The Milky Way and Andromeda are not floating freely. They belong to a small family of galaxies called the Local Group. About 50 galaxies in total, ranging from large spirals down to tiny dwarf galaxies, all bound together by gravity, drifting together through space. Beyond the Local Group, the universe is running away from us. Dark energy, whatever it actually is causing the universe to expand at an accelerating rate. Distant galaxies are receding faster and faster. Some are already moving away from us so fast that light from them will never reach us again. They have crossed a kind of cosmic horizon, gone forever from the observable universe, even though they still exist. But inside the Local Group, gravity wins over dark energy. Our small family stays bound together. And over time, the members of that family will merge. The Milky Way and Andromeda collision is the beginning of something larger. Eventually, all the major galaxies in the Local Group may merge into a single enormous elliptical galaxy, a mega-galaxy containing the stars of dozens of smaller ones. And then the universe keeps expanding. The space between the Local Group and everything outside it keeps growing, faster and faster. Trillions of years from now, the merged mega-galaxy will exist in what appears to be a completely empty universe, no other galaxies visible, no light from anywhere outside, no evidence that billions of other galaxies ever existed. Whatever looks up at the sky from inside that future galaxy will see only darkness, and have no way to know the universe was ever full of anything else. We are lucky. We live at a rare moment when the universe is still fully visible, when all its history and structure is still readable in the sky, when Andromeda is still just barely visible, a faint smudge in the dark, close enough to see, far enough to wonder about. So should we be afraid of any of this? A galaxy is falling toward us. Our sun will eventually die. Earth will become uninhabitable long before the collision even arrives. The universe will expand into an empty void where the past is unreadable. Should this frighten us? I keep coming back to the antenna galaxies. Two spirals in the middle of their collision, right now, billions of light years away. And when you look at the images, at the long tidal tails, the glowing regions of new star formation, the two cores slowly spiraling toward each other, the overwhelming feeling is not dread. It is something closer to awe. Every galaxy collision we have observed produces a burst of new star formation. The violence of two galaxies merging compresses gas clouds that might otherwise drift for billions of years without collapsing. It forces creation. New stars that would never have existed without the collision. New stars mean new possibilities, new solar systems forming around them, new planets, new chances for something to begin. The Andromeda collision is not an ending. It is a transformation. And transformation always builds something that neither original thing could have made alone. And there is one more thing. The fact that we know about this at all. That creatures on a small planet around an average star inside one of these two approaching galaxies, creatures who have only been doing science for a few centuries, can point a telescope at the night sky, measure the motion of individual stars inside a galaxy 2.5 million light years away, run the mathematics forward by 4 billion years, and say with confidence what will happen. That is not a small thing. That is one of the most extraordinary things our species has ever done. We are not just passengers on a planet falling into a cosmic collision. We are the part of the universe that figured out the collision was happening. Tonight, if the sky is clear, go outside. Find a dark spot. Let your eyes adjust. Look toward the constellation of Andromeda. Use an app if you need to. In a dark enough sky, you will see it. A faint, elongated smudge. Barely there. Easy to miss. That smudge is 1 trillion stars. The light hitting your eye left those stars 2.5 million years ago, when your ancestors were still learning to chipstone. And that galaxy is falling towards you at 110 kilometers every second. You will not feel it. In your lifetime, Andromeda will not visibly move. But it is moving. Drawn by the same gravity that pulls the oceans into tides, that keeps the moon in orbit, that holds you to the ground as you stand there looking up. You and Andromeda are falling toward each other. You always have been. You just did not know it until now. 4 billion years is longer than anything we can truly feel. Long enough that the word future becomes almost meaningless. But the collision itself, the slow gravitational dance of 1.2 trillion stars gradually becoming one thing, will produce something neither galaxy could have been alone. More stars, more worlds, more chances. And somewhere in all of that, maybe something will stand in the dark and look up and wonder, the way you are wondering right now. 4 billion years from now, something may be here, or nothing. We do not know. But if something is here, if any form of awareness exists somewhere and looks up at the night sky, it will see a very different sky than the one above you tonight. No faint smudge of Andromeda, no band of the Milky Way, just the stars of a merged elliptical galaxy, orbiting a common center, settled into a configuration that took billions of years of collision and chaos to reach. That something will not know there were once two galaxies. It will not know that one of them contained an unremarkable yellow star, and around that star a small blue world, and on that world creatures who could read the sky. It will not know that those creatures stood in the dark and found a faint smudge and worked out, from nothing but light and mathematics, that it was coming. That they knew, 4 billion years early. And they looked up anyway. Andromeda is falling toward us through the dark, slowly, certainly, beautifully. The collision has already begun. It is just moving on a timescale too vast for any one life to feel. But we can know it. And tonight, that smudge is up there. Same sky it has always been in. A little closer than yesterday. Go find it.